Okay, welcome to the webinar on implementing habituation procedures in Experiment Builder. This is kind of a fun little thing to talk about. It involves some cool little Experiment Builder tricks. So hopefully it'll be interesting for you, and hopefully you can use the Experiment Builder template as a starting point for implementing your own experiments. So let's just jump right into this. In terms of an agenda today, first I just want to give a very brief overview of what Experiment Builder is and how it works. And I'll point you to some more resources where you can learn kind of the basics of Experiment Builder. Then we can go over what habituation procedures are generally, just talk about what that means. Then we can talk about the key points of the habituation example that we'll be focusing on today. So if you are watching this webinar, you probably found it on our support forum site, and this PowerPoint and the video of the webinar and an Experiment Builder example project will all be posted at that same place. So if you're watching this, just go to where you found the video and you can find the template, the Experiment Builder example. Okay, in this example, it's kind of a very generic type of habituation procedure. So basically, during the habituation phase of an experiment, the participant will view a set of 3 images repeatedly. Once the average viewing duration of the most recent 3 trials falls below 50% of the viewing duration of the first 3 trials, the habituation phase ends. And then we're going to go into a test phase that doesn't really involve the habituation, but it uses the habituation images to basically test whether there's a preference for the habituation images compared to the new images or vice versa. Okay, then after we kind of go through the key points of that example, then we'll kind of walk through the example in a more hands-on manner and just try it out. Okay, so first, I want to give an overview of Experiment Builder. So I have the habituation example opened here, and you can see it has a graphical user interface that basically involves adding these different nodes that you can see along this top strip here to a graph editor here. And the nodes fall into 3 categories: actions, which will perform some kind of action; trigger, which will typically like wait for some kind of event to occur; and then other, which involves some special nodes that don't really connect to the others. If you want to learn more, and so basically you create kind of a flow chart of what you want to happen in your experiment by adding these nodes to the graph editor and then connecting them to one another. And if you want to learn more about the basics of Experiment Builder, you can go to our support forums, which is sr-support.com. And if you go to this section, video tutorials, and then go to Experiment Builder video tutorial series, you can see a series of 11 videos here that basically describe a very simple Experiment Builder example and go over this goes over the basics of how it works. But it's not a very complicated program. It's pretty simple to use, and it's flexible. So you can do pretty, even though it has a simple like graphical user interface and it's easy to build things, you can do kind of complicated things like this habituation procedure we're going to talk about. Okay, so that stuff being said, let's go back to the PowerPoint. And habituation, generally speaking, basically involves presenting the same stimulus or set of stimuli repeatedly until the participant becomes habituated to them or used to them in some way. And it's often used in infant studies, basically to gauge how kind of habituated the infants become to a set of stimuli over time. And you can operationally define habituation in different ways. Okay, so some habituation experiments involve monitoring heart rate and using the change in heart rate as the participant views the same set of stimuli over and over as an indicator of habituation. Since we're kind of talking about eye tracking, we're going to focus on this other way you can measure it is by looking at like a change in viewing duration. So if you present, for example, an image to a participant repeatedly, at some point the participant might lose interest in it and not look at that image as much, and that change in viewing duration can be an indicator of habituation. And while I was preparing for this webinar, I found this nice paper that gives kind of an overview of habituation and can provide you some more details about that kind of stuff. So you might want to check that out. But one of the great things about using an iLink system is that it gives you access to the eye data basically in real time. So you can basically calculate and log the viewing duration of the stimuli in real time online, and then use that as a measure of when habituation can be said to occur, and then only proceed past some habituation phase when that occurs. And so we're going to talk about how to do that today in Experiment Builder, and we're going to talk about it in the context of this example that's called habituation. And this example consists of two phases, a habituation phase and a test phase. Okay, and in the habituation phase, the participant will see the same 3 trials over and over again until habituation is complete. And by trials, I mean the presentation of one image. So each trial is going to present one image for 8 seconds. And these images are from 3 different categories. So there's one picture of flowers, one picture of trees, and one picture of bikers. And as the participant views these, the viewing duration is going to be measured, calculated, and logged. And then starting on the 6th trial, if the viewing duration of the most recent 3 trials is less than 50% of the viewing duration of the first 3 trials, the habituation will be considered complete. So you can imagine there's going to be a little bit of calculation involved to do that checking. It's not super complicated, but there's a little bit of calculation. And then another kind of just thing that this example illustrates is if the participant doesn't seem to be habituating over time, then if 12 trials pass without meeting that those criteria, then the habituation phase will end anyways. Okay, after the habituation phase, the project will go into a test phase. And in that test phase, there will be 3 trials, so 3 test trials. And on each trial, the participant will see 2 images side by side for 8 seconds. And one of these images will be one of the habituation images, and then the other will be another image that's of the same category, but it's a new image to the participant. Okay, so on the flower test trial, the participant will see the flower picture that was shown during the habituation phase and a new flower picture side by side. And in this phase, we don't really need to collect the viewing. We don't really need to be calculating and logging the viewing duration for each of these 2 images, because this is so easy to do in Data Viewer. And usually for Experiment Builder projects, I really don't recommend implementing that type of thing, because it's just a little more work to do it in Experiment Builder than it is in Data Viewer. And Data Viewer can just give you so many different kind of dependent eye-based measures. But in this case, since we're already talking about how you can kind of calculate and log the viewing duration for the habituation phase, I figure might as well do a similar thing for the test phase, and just that way we at least have like one very simple measure of how much time do they spend viewing the new image versus the habituation image in the test phase. So we're going to do that too in this example. Okay, so before we get into the hands-on kind of like inspection of the example, I thought it would be useful to hit some of the highlights of kind of the tricks involved in the example. So first of all, we need to basically repeat the habituation phase until the habituation is considered complete. And in order to do that, we need to kind of, we can't predict ahead of time like how many habituation trials we need to do. We basically just need to keep going until the participant has met the habituation criteria. So to do this, we basically are going to have like a sequence inside of a sequence, and the outer sequence will be called the phase sequence, and the inner sequence will be called the trial sequence. And this is a trick that's discussed in another webinar on repeating blocks based on participant performance, but it's using the same trick as in that webinar. So basically, you have nested sequences, and a sequence just for a reminder, in Experiment Builder is it's kind of like a looping structure. So it allows you to repeat the same basic structure over and over. And what we're going to do is, for each iteration of the outer phase sequence, we're actually going to go through all of the rows or trials of the inner trial sequence, but we're only going to actually execute the trial if the phase value of the phase sequence matches the phase type value of the trial sequence. Okay, so basically, we're not going to try to use the split by property of the trial sequence, which typically allows us to do a subset of the trials or rows of a sequence. Instead, we're going to go through all of the trials of this inner trial sequence for each iteration of the outer phase sequence, but we're going to end up skipping all the trials that aren't relevant. So basically, we'll compare the value of the phase column of the phase sequence to the phase type column of the trial sequence. And if they match, then we do the trial. If they don't match, we just skip it. Okay, so let me show you another illustration. This is basically at the beginning of each trial, we're going to do a little check to see if the phase type equals the phase value. And if it does equal it, then we'll go down here and check whether it's a test trial and go this way for a test trial. And if it's not a test trial, we'll go over here and do the habituation trials. We'll see that in a second in a hands-on manner. But if it does, if these two column values don't match, we're just going to end up skipping the trial. So that way, each time we go through all of the rows of the trial sequence, but we're only going to execute the relevant rows. Okay, so keep that in mind. That's a little trick that we can do to ensure that we can do the habituation phase as many times as we need. And we can do it as many times as we need because we're basically going to have a variable called habituation finished. And this is like variables in Experiment Builder just kind of float around in the graph editor, and they don't connect to the other nodes. So they're just used as a way of storing and getting values, just like in any kind of programming language or in math generally. You have a variable that can take on a value, and its value can be changed, and its value can be accessed. And so we're going to have a variable called habituation finished, and it's going to start with a value of 0 at the beginning of the experiment. And then after we go through all of the rows/trials of the trial sequence, then we're going to check, did we basically meet the criteria for finishing habituation? In other words, has this habituation variable been changed from its original value of 0? And if not, then we're going to go down here and recycle. Let me just jump back for a second. We're going to recycle the row from the phase data source, and that way we'll effectively keep only doing the habituation trials. So after the trial sequence, we check to see if habituation, the criteria has been met, and if not, then we're just going to redo the entire habituation phase again. Okay, so that's how we're kind of generally going to recycle the habituation trials. But now we need to talk about how we're going to determine whether the habituation finished variable should become 1 or not. Basically, how we're going to determine whether the habituation criteria have been met. So first, we need to calculate the amount of time that the participant spends looking at the image on each trial. Okay, so we have another webinar on the accumulated looking paradigm, and this uses a similar trick as to what I'm about to describe. But basically, what we're going to do is present the image here, and we're going to have a variable called time accumulated habituation image is what that stands for. And at the beginning of the trial, before we present the images, we're going to set that to 0. Basically, this variable is going to log how much time the participant spends looking at the image for each trial. And at the beginning of the trial, we reset its value to 0. Then we start the trial and present the image. And then we start a little looping structure here. So we go to a null action. And when you get to a null action in Experiment Builder, basically nothing happens. You're just waiting, okay? And so we present the image, then start waiting. And one of two things can happen here. Either the trial can time out, or the participant can look at the image. So we have an invisible boundary trigger here that's linked to an interest area that surrounds the image on our display screen action. And when they look at the image, we're going to go and start waiting again. And at this point, while they're looking at the image, one of two other things can happen. Either the participant can look away from the image or the trial can end. So these two timers have durations of 8 seconds, and they're set up so that their start time is based on the time when the images are displayed. Okay, so these timers aren't getting reset if we loop around in the structure. So we look at the image. While looking at the image, wait for the participant to either look away or for the trial to end. And if they look away, then we're going to update our time accumulated hab image. So basically this update attribute action is going to add to this variable the difference between the time when they looked away and the time when they looked at it, which is basically the most recent on image duration. So it's like just now, how much time did the participants spend looking at the image? And let's add that duration that they just spent looking at the image to our little variable. And it'll loop back here. And then at that point, either the trial can time out or the same thing can happen again. They can look at it again. And if the trial times out while they're looking at it, which would mean we're at this point here because the invisible boundary on image trigger would have fired. So if the trial times out while they're looking at it, then we're going to do one final update to say the difference between the time it is now and the time when they just looked at it. So we're basically logging how much time the participant spends looking at the image to our little time accumulated hab image variable. Okay. So that's how we're logging the amount of time they spend looking at it. And then after the actual habituation, it looks like I have a typo. I'll fix that in the example before I upload it. But after the habituation trial events have ended and we've stopped recording and we just kind of exited that sequence, we're now going to update a variable called the look durations list. And this is going to be a list variable. So in any programming language, you can have something called a list, or in some languages, it's called an array, which is basically a variable that can have lots of different values in a list. And in Python, which is the scripting language of Experiment Builder, these types of variables are called lists. And so what this little update attribute action is doing is taking that value that we just calculated in terms of, which is storing the time that the participant spent looking at the image, and it's just appending it to our list. So it's kind of just adding another value to our list. At the beginning of the experiment, this list will be empty, and on each trial, we'll add a new value, and the value that we're adding is going to be the amount of time the participant spent looking at the image for that most recent trial. And there's a kind of a little quirky thing here in Experiment Builder. So basically, when you use this append method in Python, that acts directly on this list. So it's going to just affect the list automatically. And if you were just writing this out in Python, you wouldn't even say something equals something. You would just say look durations list append so-and-so. But since these update attribute actions, they need something to go on the left side of the equation and something to go on the right side of the equation, we're just putting a dummy list over there. Basically, this doesn't like return a value. Like when you're first using Experiment Builder, you might be tempted to say look durations list equals look durations list append, but that would end up actually clearing out your looks duration list because this append doesn't return a value. So this is basically just a placeholder there. Don't worry about it too much. You can just copy the method that's used here. But anyways, we're adding our look duration to our list variable that's storing the look durations for our trials. And then we're gonna check. So now we have to start checking to see if the habituation criteria have been met. And we can do that by using conditional triggers. So these are like logical if-then comparisons. And it's a little bit hard to see here, but if you zoom in on an Experiment Builder project, you'll see there's a little check mark here and there's an X mark here. And when you select the trigger, you set up a logical comparison. And so in this case, we're comparing a variable called current trial number, which is a variable that just increments on each trial. So first trial it's 1, second trial it's 2, etc. And it's saying if that value is greater than or equal to 6, remember we don't start checking to see if the habituation criteria have been met until after trial 6 or until we get to trial 6. And so if we are at trial 6 or later, then let's go on down here and do a further check. If we're not at trial 6 or later, let's just skip ahead and don't do anything. But if we're at trial 6 or later, and we're going to be on this habituation branch, then we're going to say, you can see here, we're saying look durations list value, and you can see we have a little index -1 plus look durations list value -2 plus look durations list value -3. So that's the way you can grab the last, second to last, and third to last items from the list. When you put a negative, that's like the index for the list, then it grabs from the kind of end of the list rather than the beginning. If you want to grab the first items in the list, you would start at 0 and you put 0, 1, and 2. So what we can see here is we're saying, let's take the last 3 items of our look durations list and add those things up. And then let's compare them to the sum of the first 3 items here divided by 2.0. I just put 2.0 because I wanted it to be to have decimals. And that's the way that you need to have what's called a float type of a value here to make the result of this calculation also be a float. And so we're going to say if the sum of the look durations of the most recent 3 trials is less than or equal to half of the sum of the first 3 trials, or we're at trial number 12, we've done 12 habituation trials, then if either of these things are true, then we're going to go down here to a little update attribute action, and this is the one that's going to set our habituation finished variable to 1. Okay, so this is where we're basically making the determination of whether habituation is complete or not. And if it is complete, we set the habituation finish to 1. Okay, then let's imagine we have done, like, we're on trial number 7. So we've done 2 rounds of 3. Remember, each kind of full cycle of the trial sequence has 3 habituation trials in it: a flower, tree, and bikers. And if we have done 2 sets of 3 and now we're on the 3rd set of 3 and we've completed maybe only 1 of those sets of 3, but we have met the habituation criteria, then we want to make sure to skip any further habituation trials that are in our current kind of set of the trial sequence. And so in that case, what we're going to do here is say, if we are at a habituation trial, let's check to see if our habituation finished variable is equal to 0. If it is equal to 0, we have not completed habituation, we'll do another trial. But if we have already met our habituation criteria, then that variable will be 1, and in that case, we're going to just skip the trial, just as we would do for all of the test trials in that kind of iteration of the trial sequence. Okay, so that at that point we will have completed, like once we kind of get our habituation finished variable set to 1, then that means we have met the criteria for finishing habituation. And basically, we can say when we get back to the end of our trial sequence, so we go through all the trials here and we get to the end of that, we're going to check our variable again, habituation finished. And in this case, it's not going to be equal to 0. So in all of the kind of initial rounds of the habituation procedure, remember it's going to be equal to 0 because we haven't updated it yet. And in that case, we keep just recycling the outer phase sequence. But if it's not equal to 0, then we're going to do nothing, which is going to effectively move us on to the test phase because we're going to advance one row of the phase sequence data source. Okay. And then when we get to the test trial, it's basically almost identical to the habituation trial in terms of logging the times. We just have one kind of loop of things to log the amount of times that the participant, to log the duration that the participant spends looking at the new image, and another little loop here to log the duration that the participant spends looking at the habituation image. So again, this really isn't necessary to do this. We could just present the two images and have a timer below it and then blank the screen after 8 seconds. But since we're already talking about these techniques, we might as well just use them and log those times as well. And that way we'll just have a very simple variable for the habituation duration and another variable for the new image duration, and we can quickly check the amount of time the participant spends looking at those things. We can quickly compare them. But we don't need to do that because you can do it in Data Viewer. But I just wanted to mention that. Okay, so now those are the basic tricks. And if that all seemed confusing, don't worry, let's go through it now in a more kind of like detailed way. So now let's just walk through the experiment. So at the beginning, we have some instructions that are just, you can change the text here, but this is just some instructions to the participant or the experimenter. Wait for a key press, and then we're going to do the eye tracker calibration here through the camera setup node. And we have our little results file here that will allow us to save a tab delimited text file along with our eye tracking data file in our results folder of the project. And this will give us all the variables of our data source columns, all the values of our data source columns and all the values of any variable nodes in the project. So that way, if we want to check just like how much time did they spend looking at the new image versus the habituation image for the test trials, for example, we'll have that all in a text file. Okay, then we're gonna start the real experiment. And you can see we have our phase sequence here. And this is the one that has a data source with just one column and 2 rows. And so we have a habituation phase and a test phase, okay? And so in a normal setup, if we didn't use any recycled data line nodes, then this would only occur 2 times, okay? And we'll go in there and we'll see that on each iteration of the outer phase sequence, we're gonna get to this trial sequence. And you can see it has a iteration count of 6. And if we click, it has its own data source here. And that means that we're gonna do 6 iterations of this trial sequence. And it doesn't have any split by, so that means on each phase of the experiment, we're actually gonna go through all 6 rows of this inner trial sequence, okay? But remember, we're gonna skip the rows or trials that don't apply to the current phase. Just keep that in mind. And then after we go through all 6 of these, then we're gonna just check, has our habituation finished variable been updated or changed to 1? Remember, we're gonna change it to 1 once the habituation criteria have been met. And then if it hasn't been changed to 1, then we're gonna recycle the data line, and you can see we're recycling the phase data sources line. And so what this is going to do is, instead of moving on to the next row of the outer phase sequence, we're going to repeat this same first row here. And so we're still going to be in the habituation phase. okay? And that's going to basically determine which trials get executed and which trials get skipped. So on each phase of the experiment, we're going to get to this trial sequence and go through all 6 iterations, but I just double click to go inside of there. At the very beginning of the sequence, we're going to hit this check to do trial conditional. And remember, it has a check mark here and an X mark here, and we have a little logical comparison. And so if this column here, our trial data source phase type column, is equal to our phase sequences data source phase column, then we'll do the trial. Otherwise, we'll just go down to a null action and just skip it, and then it happens super fast. So basically, on the habituation trials, when it gets to the test rows of the data source, it'll just skip these super fast. And then when you get to the test trials, it will skip all the habituation rows. So that's a way we're controlling which types of trials actually get executed as we go through the trial sequence. Okay, then let's imagine that they do match, and so it is a trial that we should do. In that case, we're going to hit this update attribute action, and it's going to reset our variables: time accumulated habituation image and time accumulated new image. So we have this variable is the only one that's going to be used in the habituation trials, but in the test trials, we have a habituation image and a new image. And we're going to log the amount of time they spend looking at the habituation image for all the trials, and we're going to log the amount of time they spend looking at the new image for the test trials. And so we're just resetting those variables back to 0 at the beginning of each trial. Okay, then we're going to check what type of trial are we doing? Are we doing a test trial, or are we doing an habituation trial? And so we actually could have checked either the trial data source, this column, or we could have checked this phase data source column. It doesn't really matter, but in this case, we check the trial data source phase type column, and if it equals to test, and that means we're going to go over here and do our test trials. So if we scroll down here, you'll see this says recording test. Let me just fix this typo here. Okay, and this one is for the habituation trials. So if that column's value does not equal to test, then we're going to go over here to our habituation sequence. And these two sequences are what are called recording sequences in Experiment Builder. So these are not used for looping in any way. They're just used to control the recording of the eye tracker. So you can see they both have an iteration count of 1, which means when we get to that sequence, it's only going to happen. It's only going to iterate. It's only going to do 1 iteration. It's not going to cycle and do multiple iterations. And the only reason we're using a sequence here is because it's only through a sequence that we can control the recording of the eye tracker. So whenever you add a sequence to the graph editor, it has a property called record. And if we look at our other sequences, that property is unchecked. But when we get to the point in our experiment where we actually want to start recording eye movement data, then we put those inside another sequence and we check this property record. So we have 1 recording sequence for our habituation trials and 1 recording sequence for our test trials. And before each of those sequences, we use one of these prepare sequence actions, which loads up all the trial stimuli. Like if we were doing videos, it would load them up into the video card memory, images, it's like sounds, etc. And so this basically just prepares for the upcoming trial. And then we go in here and start recording. And this is where kind of the critical action in terms of monitoring the eye position, the look durations on the image occurs. So first we want to present the habituation image. And so if I double click on this display image action, you can see we have an image resource that was added using this little button here. And just like in other Experiment Builder projects, we would expand that a little bit. Instead of using a static, let me delete that so you would see, instead of using like the same image on every trial, we want to grab that image from the data source. So we find our little trial data source. Let me just go a little slower. Whenever we click on any property and we see this little button, that allows us to make a reference. And so I'm going to click on that and we can find our trial data source here and find our habituation image. column and double click on that. And that means instead of seeing this image every time, they're going to see whatever image is specified in this column here, because we're making a reference to that column. Okay, so that's how we present the image. And then we have an interest area here, and it may look like it's not on top of the image, but when we actually run it, its size and location will be updated to match this image resource. So you can see its location property references the habituation image location property, and its width and height properties reference the habituation image resources width and height properties. So if we moved this image around to somewhere else in our spreadsheet, then this interest area would, if we move this around to somewhere else in our display screen editor, then this interest area would be updated as well. Okay, so just so you know, this is going to be an interest area that's going to fit exactly around this image resource. And then after we present the image, then we're going to start our little check loop to check how much time they spend looking at it. So once the image is presented, as we discussed before, one of two things can happen. Either the participant can look at the image, so we have an invisible boundary trigger node here, and its region type is set to an interest area, and it is linked to our interest area around there's only one interest area, so it's linked to that interest area that we were just looking at, that blue box that's going to go around the image. And so when the participant looks within that box, we'll get to this point here. And at that point, they can either look away, and you can see this trigger is really almost exactly like this trigger, but it's within properties unchecked. So that means this will fire when they look outside of that interest area. Okay, and if they look outside of that interest area, then we're going to say let me expand this. Our accumulated, expand it a little more, time accumulated habituation image variable, which remember was set to 0 at the beginning of the trial, it's going to be equal to its current value plus, in parentheses, the difference between the time when they left the image and the time when they entered the image. So this kind of difference calculation here is going to be the amount of time they just spent looking at the image, and we're going to add that time that they just spent looking at the image to the current value of our time accumulated habituation image. So we're basically just updating, like, okay, let's say they look at it for 300 milliseconds and look away. We're going to add 300 milliseconds to that and go back here. Then they look at it for, let's say, 600 milliseconds. Then we're going to add that 600 to that 300, and it'll have a value of 900. Okay. So basically, anytime they look away, we're updating the amount of time they spend looking at it. Whenever we're at this point where the eyes are currently off of the image, another thing could happen. 8 seconds could pass, and notice how this start time of this timer trigger is linked to the time when the images were displayed. So if we're ever at this point and 8 seconds have elapsed since the time when the image was displayed, then we're just going to end the trial. And the same thing can happen if they're on the image. So if the participant is currently looking at the image, if 8 seconds elapses, then we're going to end it here. The reason why I needed to use 2 timer triggers is because if they're on the image, then we need to add that last little amount of time that they spent on the image to our variable. Okay, so at the end of the trial, if they're currently on the image, let's do one last update of our time accumulated habituation image and add the current time minus the time when they started looking at it this most recent round. So this is the way we're logging the amount of time the participant spends looking at the image. Okay. Then after that series of events occurs and the habituation trial has ended, we're now going to add the duration that they spent looking at that image on that most recent trial to our look durations list. And we talked about how this appends the value to the list. So we're basically just adding a new value to our list, and we're keeping any old values from previous trials. If this is not the first trial, we're still going to keep those previous values in the list, and we're just adding and we're just appending a new value to that list. So our look durations list variable is going to store the durations of all the look durations for all the trials. Okay. Then we're going to check, are we at trial number 6 or more? Later we'll see that we have a little variable called current trial number. Actually, I'll just show you right now, right here, and it starts the experiment with a value of 1, and at the very end of each trial, we add 1 to that trial number variable, and we're only going to get to this point if the trial wasn't skipped, so it's only incremented when we actually do a trial. And what we're going to do here is, after we append our look duration, we're going to check, are we at trial number 6 or greater? Because remember, we only start checking for whether habituation is complete after we get to trial 6, or when we get to trial 6. And so we're saying, are we at trial number 6 or greater? If so, let's go over here and do one other check. And this other check is the way we really do the habituation criteria check. And so what we can see here is we're saying if, and we have a little equals here because we're doing a little calculation, if the last item in our look durations list, so that, let me just show you the way you can do this. I'll do it from scratch. You can type equals, and then we're going to say, let's grab our look durations list variables value, but we don't want to grab all of the look durations in that list variable. We just want to grab one of them, which is going to be the last item in that list, plus that same variable's value, but this time let's grab the second to last item in the list, and then the third to last. So this is what's going to give us the sum of the duration of all the look durations for the most recent 3 trials, okay? And then we do a similar thing down here, except we use 0, 1, and 2, which will give us the durations of the first 3 trials in the list. And in this case, we're also dividing by 2 because we want to check to see if the most recent 3 trials duration is less than 50% of the durations of the first 3 trials. It's really the same as an average duration, but we don't need to divide by 3 on both of these because the result would be the same. So I'm just comparing the sum to the sum divided by 2. Okay, so if in our most recent 3 trials we've fallen below 50% of the look duration, or we're at trial 12, then we're going to say, all right, habituation is complete. So let's now update our little variable called habituation finished and set its value to 1. Okay, and that's basically the end of the trial. If habituation is not complete, we're going to get a little null action then where nothing happens. But then we're going to add a row to our tab delimited text file that's just going to store the values of all of our data source columns and all of our variable nodes. So all of these things are going to become columns in that tab delimited text file. And what we're doing with this little guy here is adding a row. So that's why it's called add to results file. It'll add a row to our results file. Okay, and then finally we're incrementing the trial counter here, as we discussed. Okay, and once we get to the point where habituation finished is set to 1, then as we go through the rest of any remaining habituation trials in our current kind of cycle of the trial sequence, we're going to effectively skip any remaining habituation trials by going to this null action skip trial, because habituation finished is no longer equal to 0. So we're going to go over here and skip any remaining habituation trials. And then once we get to the end of all 6 of the rows of our data source, our trial data source, we're going to check, does the variable that's called habituation finished now have a value that is equal to 0 or not equal to 0? If it's equal to 0, we're going to recycle our phase data source row and effectively repeat the habituation trials again. So we would repeat these 3 trials again. If it is not equal to 0, we're not going to get to our little recycled data line, and we're going to go over here, and that's going to advance us to the next row. And then from there, we're gonna, on the next iteration of 6 of the 6 rows of our trial sequence, we're gonna skip the habituation trials because they will no longer match our phase data source, phase column, and we will only do the test trials. And so we will always go over here for the remaining cycle of the trial sequence. And in that case, it's very similar in terms of like the kind of trick that's used, but basically we present 2 images. So now we have one image that is called habituation image resource, another one that's called new image resource. And you can see these are getting the source file name and the location from references. So this is for the habituation image and this is for the new image. They're referencing these columns here to get the files, the image files to use. And I just put blank here for the habituation trials because there is no new image for the habituation trials. But for the test trials, we're going to have flowers 1, flowers 2, trees 1, trees 2, etc. And they're getting their location from this column here. So we might not, or we probably don't want the habituation to always be on the left and the new image to always be on the right. And so these image resources get their location from these location columns, and that way they can switch position from trial to trial, and the participant won't always know that the habituation image is on the left and the new image is on the right, or vice versa. And if we go back to the display screen action, this interest area, the participant doesn't see the interest areas, by the way. They're just used to help us with our invisible boundary triggers and to help us in data analysis and data viewer. But these things are going to move around because their location, width, and height properties refer to the image resource. So as the image resources move around, the interest areas will move around as well. So that takes care of that. And if we go back to the sequence here, it's really that same type of looping structure. So see how there's an invisible boundary on image and an invisible boundary off image. But we just have 2 sets of them because we have one set for the habituation images, and we have one set for, or I should say habituation image, and another set for the new image. And each one is just updating the appropriate variable. So in the new image loop, we're updating the time accumulated new image variable. And on the habituation image loop, we're updating the habituation image variable, which is actually the same variable we used in the habituation trials. And we have to have 3 timers here because we have one for if they time out while they're looking at the new image, one for if they time out when they're looking at the habituation image, and we need to do one last update. And then we have one timeout timer in case they're not looking at any image, and it will time out from this null action. Okay, so that is how this works. I mean, I know it seems like a lot of nodes maybe, but the concepts are actually pretty simple. You're just a series of conditionals, variables, and invisible boundary triggers are really kind of, and some timer triggers are really like the main kind of tricks involved in this experiment. So let's do a little run through and see how it works. And I've discovered that when I'm using this webinar software, when I run the project, when I run an experiment builder project, it kills the video recording of the screen capture basically. And so I'm going to turn on a little webcam that I have pointed at the screen, and I have a host PC that I have in mouse simulation mode. So I'm just going to simulate the eye movement so we can have a little bit of control, and I'll try to talk through what I'm doing because you won't be able to see the host PC. But I'm going to turn on this webcam and we can do a little test run. Okay, so I have a webcam. Let me do a little better pointing. Hopefully you can see what's going on. I know it's a little bit of a blurry image, but hopefully you'll get at least an idea. So I'm going to do a test run. For those of you who are already kind of experiment builder veterans, you should never do a test run for real data collection. You should always deploy the project. You would already know this if you're a veteran. You should always deploy the project and then run the executable. So when you deploy a project, it creates a new project folder and you would run it from there. But since we're just doing a little test, we can do a test run from within the experiment builder interface by clicking this button or going experiment test run. And it actually gives you a warning, don't use this for real data collection. So that's fine for our purposes here. So I'm gonna say, by the way, test runs operate just like running a deployed version. So you can always do a test run to make sure things are working. So I'll say, yeah, that's fine. And now it's gonna build the project. And now it'll ask for the name of the eye tracking data file. And I'll just use the default test.edf. Okay. We should see some instructions at the beginning of the experiment. Okay. And I'll press a key. And at this point, we're in the camera setup. And this is where you would normally calibrate the eye tracker. But since I'm running the host PC in mouse simulation mode, I've already calibrated my mouse. You actually can do that. It should be calibrated from the beginning by default, but I've already calibrated it. I'm going to skip this by pressing O for output record. And now we have the first habituation image, and I'm just keeping the eye cursor, the gaze cursor on that image. I'm moving it around a little bit, but keeping it within the image. So they look at it for the whole 8-second period. Maybe I'll move it off just briefly and back on for the second trial. Okay, now we have the third trial. So I'm just keeping it on the image. I'm basically trying to pretend like these are new images, so they're interesting. Now we have the same image, so maybe the eye wanders off that image a little bit, but comes back. Okay, maybe wander off briefly and come back, still looking at the image for most of the time. Okay, and then wander off briefly, come back, maybe wander off briefly again and come back, but probably not enough to fall below 50%. So that's trial number 6. Now let's say this is the third time I've looked at it. I'm no longer interested. So I'm just keeping my eye off of that image, maybe just briefly on and off. Okay, like, this is boring to me now. I'm habituated, so I'm gonna look away, maybe briefly on and then off. And then, so it seems like from those last 2 trials when I really just didn't look at it much, now I'm moving the gaze cursor back and forth. We're at the test trials. So now we have 2 images, and I'm just moving the eye back and forth from the 2 images here so we can get some data on those. But during the habituation phase, you could see as the gaze duration on the image decreased enough, we ended the habituation phase automatically. Okay, so then we went through the 3 test trials. I just moved the gaze cursor back and forth. We turned the webcam off. We did the test trials after the habituation was complete. Let me just go into the folder where I've saved this data, and I'll go into, this is the project folder. And whenever you do a test run or run a deployed project, you have a results folder, and it will create a subfolder for each participant. And I use the default name test, so we have a test folder. And this is the eye tracking data file, but remember we also saved it. We could open this in Data Viewer and check out the data. I'll kind of leave that to you if you want to try it out and check that out, but I'm just going to show you the results file. I'll just open this with Excel. Okay, let me expand these columns. So remember we had that results file and the add to results file. So you can see remember in the habituation phase, I said for the first trial, keeping it on the image almost the whole time so we can see we're accumulating. There's a little bit, maybe like a millisecond or 2, just of rounding basically almost. So it will be within a millisecond of, or maybe 2 or 3 milliseconds of the like timer duration. But then on the trial where I moved it off briefly and came back, you can see it's a little bit less. And then as I habituated, it got less and less. And then finally it got to the point where the sum of these 3, if we added those up, the sum of these 3, these are the last 3 habituation trials here. If we added these up, that's going to be less than half of the duration of these. And I'll leave it to you to check the math if you want to, but basically it looks right to me. So then we moved, after that habituation was complete, we moved on to the test trials. So these last 3 rows are the test trials, and we have the duration they spent on the habituation image and the duration spent on the new image. I would probably expect maybe more duration on the new images, and maybe I didn't simulate that well enough, but I'm not an expert in this paradigm, so you have to test your own hypotheses there. But basically, you can see we have this kind of data we need for a very kind of simple check of the habituation procedure to make sure it's working. And if we wanted to do a simple comparison of look durations across the image types for the test phase, you can do that. And if you wanted to get into more detailed measures, then it's just a matter of importing your EDF files into Data Viewer, and then you can calculate all kinds of measures of first time they look at each image, how many times do they visit it, leave it, and come back. So many different, like dozens, if not hundreds of different dependent measures that you can output from Data Viewer. But basically, that's how the habituation procedure can be implemented. That's one version of the habituation procedure, and a very simple one that can be implemented in Experiment Builder. If you have any questions about how this works, or about maybe if you want to do a variation of this and you're not sure, or you just have any questions in general about Experiment Builder, Data Viewer, any of our software, or the eye trackers, don't hesitate to get in touch. You can email us at support@sr-research.com. You can go to our support forums and post on there if you want. Oops, I'm logged out, but you can log in and post there. You can call us, whatever you want to do to get in touch. We're happy to help with any questions you have. So good luck with your experiments. Stay safe and healthy, and happy tracking.